And I'm still in this section here. And as I said to you the last day, this is the last section really. So what I want to try and do today is finish off this set of slides. And I also want to talk a little bit through the assignment specification. Hopefully you've had a chance to at least skim over it before today. And in relation to the lab, if I just go into that for a second, everybody should really have completed this part of the lab that is to be submitted, which I think brings us up to this section here. And there are two more sections in the lab, one to do with SQS dead letter queues, and the second one to do with filtering. The reason I've added those two sections on to the end of the lab is because you will need them for the assignment. So it's very important that you kind of work your way through these two sections as well and kind of play with the application in both of them. I give you the CDK app, you just deploy it and then you kind of play with it a little bit to make sure you understand the techniques that are being used in both of these sections. So it's very important that you work your way through those later on this week and perhaps next week as well. So let's go to the lecture notes and try and pick up where we left off the last day. So again, I have added some slides to this set. So if you've already downloaded them from before, from maybe last week, maybe you should download them again after this lecture because you'll be missing some of the slides. And so where we left off the last day was talking about the SNS service, the simple notification service. So let's fast forward to there. SNS is what we call a pub sub service, a publisher subscriber. Publisher is something that writes messages to the SNS topic. When we talk about topics rather than queues, we also maybe use the term channel in relation to a topic, or if you read articles about SNS, it may talk about SNS channels. A channel and a topic is essentially the same thing. So you have publishers that write messages to an SNS topic. Let's have a little here. And you have subscribers that read those messages, and the publishers and the subscribers are not synchronized in any way. Now, what's nice about this SNS service is that you can have many subscribers to the same topic. And as you probably know already at this stage now, when a publisher writes a message to an SNS topic, all of the subscribers to that topic receive a notification about that message, so they can process it in parallel. That's often what we refer to as the fan out pattern. Now, again, like I mentioned the last day, in this image, the suggestion might be that for the fan out pattern, the subscribers have to be SQS queues, but that is not the case. You can have a mixture of, and indeed in the lab that you've worked your way through, we had an SNS topic where one of the subscribers was an SQS queue, and it also then had a Lambda consumer to that queue, but the other subscriber was a Lambda. So instead of a queue here, we had a Lambda directly subscribing to the SNS topic. Now, where I left off though was talking about filtering. So I'm not going to go over these slides again. Don't want to be boring you with that stuff. So we left off here. And filtering, the idea is, again, you've got this fan out pattern, but you want to somehow restrict the types of messages that each subscriber receives. You may or may not want to do that. In other words, you want to filter the messages at the subscription level. And so the kind of visual that's going on here is we've got a publisher. And by the way, you can have many publishers, but let's just stick with the image. We've got a publisher, and just based on the color coding that we're using here, it looks like the publisher is publishing different types of messages. However we categorize the type doesn't really matter. Over here, then we have the subscribers, but we can see, for example, this subscriber isn't receiving all of the messages. It's only receiving a subset of them. And so that subset is described using filtering. So we need to know the mechanics of how we specify filtering for a subscriber. That's really where I think I left off the last day. Before I show you the mechanics of how you do it, first of all, I'm saying here that the filtering can be based either on the body of the message or on what are called attributes of the message. Now, I haven't talked about attributes at all so far, and we don't really need to go into what might constitute attributes. All we need to know at this stage is that the body of a message is typically a JSON structure, and the attributes will also be specified in a JSON structure. In other words, the attributes will be key value pairs, and the body will be key value pairs. And I'm saying here that you can filter either based on the values of certain attributes or the values of body properties. Yeah. So there is a similarity really in terms of the nature of the filtering, because both the body and the attributes are specified in JSON form. And as I've just said, the filtering is going to be based on, because they're both JSON structures, then the filtering is based on the value of certain properties, be it of the attributes or of the body itself. Down here, I'm saying that there are kind of essentially three types of criteria that you could use for specifying your filtering, whether you're doing attribute or body-based filtering. There is string filtering. You would use string filtering, obviously, if an attribute's value was a string or a body property value was a string. And for string filtering, you can either specify a list of values that are allowed for that string attribute or body property. In other words, you can specify, look, if the string is equal to one of the values in the array that you specify as the allow list, then you want that message to be passed through to the subscriber. Alternatively, you can specify what's called a deny list. Both of these are going to be arrays of strings, okay? But in the case of the allow list, you're specifying what you want to allow to go through to the subscriber. In the case of the deny list, the array of strings is specifying what you do not want to go through to the subscriber. And so sometimes it might be easier to specify a deny list because maybe the allow list is just too long. There are 40 entries in the allow list, whereas the deny list might just have 2 entries in it. So it's just less typing, I guess. Or you can specify that the string value property has to match some prefix. Yeah. Here you're specifying whole values. Here you can specify just the prefix that you're looking for in the string, be it the string of an attribute or the string of a body property. For a number filter, it's where the value is a numeric value as opposed to a string value. And again, you can specify the filter as an allow list. So it's going to be an array of numbers. Or you have all of these other greater than, less than, between, and I think you've got a less than or equal to, and et cetera, et cetera. Um, yeah. The third option is where you're just going to say, look, if, let's say we're using attribute-based filtering, if the attribute exists, then I want it to go through. If it doesn't exist, I don't want it to go through. Or in the case of body-based filtering, if the body of the message has a particular key within it, then I want the message to go through to the subscriber. Otherwise, I don't. So it's a much simpler type of specification. Okay, they're the three different ways three different criteria that you can use for specifying your filtering, whether it be attribute-based or body-based. So let's see an example. And okay, so all right, yeah. So let's supposing this is our architecture, and this is actually the architecture that you're seeing here is, if I switch over to the labs, and if we fast forward to this section here on filtering, and you're told here to download an archive, well, the archive that you're downloading is essentially the app that I'm describing here. Okay. So we've got an SNS topic. We're going to use the AWS CLI for convenience as a publisher to that topic. We've got two subscribers. One subscriber is a Lambda. The other subscriber is an SQSQ. And this is the way I'm kind of indicating that we're going to have filtering on the subscription of both of these subscribers. Okay, and so for example, I'm saying here, if we just focus on the Lambda subscriber, I'm saying here that the Lambda subscriber is only wants messages with the attribute user type. So I mentioned there a few moments back that the attribute is going to be a JSON structure. And what we're saying here is in the attributes JSON structure, it has to contain as one of its keys the key user type. And the value for that key can be either equal to student or lecturer. If it's one of those two, then I want messages like that to go through to my Lambda subscriber. If user type doesn't exist at all as an attribute, or if the user type attribute has some value other than student or lecturer, then I do not want those messages to be passed on to my Lambda subscriber. Okay, that's the objective. Here's how we actually code it. So demo topic is a reference to an SNS topic that I would have created earlier in this script. I'm adding a subscriber. The type of the subscriber is Lambda. That's all consistent with what I've been showing up here. And this is how we encode the filtering. Now, I've told you that there is two types of filtering, attribute-based filtering and message body-based filtering. Well, we can tell straight away, I can tell straight away that this is attribute-based filtering that we're specifying here. Later on, I'll show you how you specify body-based filtering. And when I show you that, then you will be able to determine whether one is body-based or attribute-based. But in this case, anyway, I'm just telling you this is attribute-based filtering that we're doing here. And so what you do inside here is you kind of describe what you're looking for in the attributes. Here we're saying that we're looking for an attribute called that exactly, called user underscore type. And the type of filter that we want to apply to it is a string filter. And in terms of the condition, I'm specifying an allow list, and I'm saying student or lecturer, which is an array of strings. So the net effect is that I'm allowing any message that has the attribute user type associated with it, and the value of that user type can be that or that. Okay. So the syntax is a little bit clumsy, but that's how you interpret it. It's kind of declarative, but it's strictly like from a kind of programming perspective, string filter is actually a function, because here we're calling a function and we're passing an object to it, but I wouldn't I wouldn't kind of try and interpret it just purely from a coding perspective. Uh, Look at it more from a declarative perspective. So I'm declaring here anyway the nature of the filter that I want to associate with this subscription. So if I switch over to VS Code, and what I'm showing you here now is the actual the project that you will download in the lab, in the last section of the lab. And so if we look at the CDK file, let's quickly scan over it. Here I've got my SNS topic. I've got a queue, because one of my subscribers is going to be a queue. I've got my lambdas. This looks like the lambda that is going to be a direct subscriber, although you can't tell from looking at that code, but I just know from the name. That's the lambda that is a direct subscriber to the topic. This is the lambda that's a consumer to the queue. And here we go. I'm adding a subscriber to my topic, and this is what I showed you on from the PowerPoint slides. This is the second subscriber. Okay, this is a NSQS subscriber, and for the moment, I've just commented out the filtering. I'll explain this in a moment. So we'll apply some filtering to that as well. So I've already deployed this structure. Now over here, just for demo purposes, the message that I want to send to the SNS topic is our simple structure that we've seen before. So that's the message. That's the message body, if you like. And in the case of attributes, in my case, this is where my attributes are specified. Now, the syntax for specifying the attributes, it is a little bit long-winded, but it looks like I've specified two attributes here. There's a user type attribute and there's a source attribute. Now, as I mentioned there at the beginning of the lecture, uh, let's not concern ourselves with how do I come up with these attributes? We're not really interested in the modeling side of this. We're just interested in the mechanics of how SNS works and how filtering works. So just take what I'm giving you here as attributes. We won't get into explaining how did I come up with these particular attributes. So I want to associate two attributes with my message, user type, and you have to specify what is you have to specify what type of values can be assigned to this attribute. And here we're essentially just saying that it's going to be string values. And the actual value I want it to be, in this case, lecture. The second attribute we're not concerned with now. It's going to be ignored anyway by the filter that we've defined. So let's send the message to my topic. And just check in CloudWatch. Now, hopefully I won't have that kind of delay problem that I had last week with CloudWatch. So I don't have any logs at the moment. That's okay. Let's send the message and the attributes that I've just shown you. Now, I played with it a little bit earlier, so this is the command to send a message to an SNS topic with attributes, and maybe it'll be a little bit easier for you to read it if I open up the README file. So this is the command that I'm going to use. Yeah. We've seen this before. AWS SNS publish the ARN of the topic. And I'm saying the message attributes are going to be specified in the file called attributes.json, which I've just shown you. And the actual message itself is also going to be specified in a file called message.json. You don't have to put the attributes in the message into files, but it's easier to type, I guess. So let's send off this, and based on the filter, which is really what we're interested in, I go back to here. If I go back to here, based on this filter that I've specified, the message should actually be passed through to this Lambda subscriber. It'll also be passed into the SQSQ subscriber because it doesn't have any filtering, so it'll automatically receive all messages. And the second Lambda that I have in this architecture is a consumer to this SQSQ, so it'll also be triggered, but we're not interested in that right now. So if I send my message from the command line, just give me 1 second now. And as before, if I switch over to CloudWatch and do a refresh, I should eventually get 2 log streams for my 2 lambdas. And this is the one that I'm interested in anyway. So the other log stream hasn't come through because it's polling the SQSQ, so that's always slightly delayed. And if I go into, so this is the log stream for the Lambda that is directly subscribed to the to the SNS topic. And surprise, surprise, it has actually received the message. It's always a challenge trying to dig out the so there's the message attributes part, which we didn't look at before. So they've come through, and the body of the message, which I always struggle to try and dig out, but it's buried somewhere inside here, I guess. Oh yeah, it's kind of up here, yeah. It's in serialized form. So the message got through to the subscriber. The filter allowed it through. If I send another message, and let's say I change the attribute to something other than lecturer or student. So if I just go back to here and I do a refresh of the log groups, okay, so the second Lambda has run now as well. If I send a second message and I want this message to not get through the filter, so my Lambda subscriber won't run, but the other Lambda will run because the SQSQ that it's feeding off of doesn't have any filtering going on. So if I just go into my attributes and change the user type to let's say admin. Save that. Send. I'll send the same message, but strictly speaking, I guess we should have changed it. send the message. Give enough time for the filter to do its processing, but no matter how many times I refresh now, I'm never going to see the message that I've just sent being processed by the process SNS lambda. So it should have gotten through by now if it was to get through. Just do one more refresh. In fact, if I look at the other lambda first, then this second lambda should have received 2 messages at this stage. Yeah, let's look at that one. So did it get 2 of them? Yeah, it's the one log stream is showing both messages. And this is the one. There you can see the admin attribute as well as the message body. But the other lambda, I go back to it, the other lambda, I do a refresh just to be sure. It is only one log stream, and in that log stream, there's only the one message. So it never received the second message that I sent. That looks good. The filtering is working. If I just go back to the CDK, I mean, you have that's essentially it, really. I've shown you how to specify filtering. The other example, you can filter on the basis of more than one attribute. And that's what I'm illustrating here. So again, it's attribute-based filtering, and I am focusing in on 2 attributes, the attribute called user type and the attribute called source. And for this particular subscription, the SQS subscription, I'm saying the user type can be only lecture. So they're the only ones that I want to put into the queue. But also the source, oh yeah, I'm using the match prefix. The source has to begin with either the prefix Moodle or Slack. So I guess if we go back to our attributes, and I have admin and I have Moodle 2023. Well, I mean, you can play around with it, but if I put lecturer here, then the message associated with these set of attributes will get through to the SQS subscriber. If I put something other than lecturer here, irrespective of what I have down here, then that message won't go through because the filter is based on both attributes and they both have to be they both have to respect the filtering that I'm describing for the SQS subscriber. So could I just well, yeah, if I leave it as it is, actually, if I leave this as admin, even though, and this says Moodle 2023. So based on those set of attributes, okay, this filter is going to allow the message through, but this filter will not let it through. Yeah. And for this one, because this filter won't let the message through either, because the user type is set to admin, which doesn't equal to student or lecturer. Okay, so what you should do later on is in the lab, you should download this application, which I provide in the last section of the lab, and essentially play around with the filters to make sure you fully understand how they work. So that's attribute-based filtering. The next thing we need to talk about is body-based filtering, but I'm actually going to just pause the lecture, the slides for a moment, and I'm going to switch over to just talk a little bit about the assignment specification. And the reason I'm doing that is, do I have the assignment specification? No, let's bring it up. So as I said, hopefully you've scanned over it, but the way I've structured the assignment specification, again, it's to develop an event-driven mini application, notionally an application for managing photos, but it's very much a skeleton. And just from an architecture point of view, so I've broken it up into 3 phases. For if you complete phase 1, then you can score between 40 and 50%. If you are aiming for higher than that, then you can aim for phase 2. Phase 2 builds on phase 1. Phase 2 will get you a score potentially of between 50 and 75%. And phase 3 then builds further on phase 2, and that's for going from 75 upwards. Now, we've just been talking about attribute-based filtering, and if you just go as far as that in the lectures, obviously you should go further. But if you just if you just have a thorough understanding of attribute-based filtering, as well as some of the other topics that we've talked about in relation to SNS and SQS, then potentially you can score up to 75%. Kind of put it another way, I have covered enough material now in the lectures and in the labs to allow you to get potentially up to 75% in this assignment. I still have some more lecture material to cover. And when I cover that, it's only when I cover the remaining lecture material that you will be able to potentially tackle phase 3. So it depends on what you're aiming for, right? But if we just look at the architecture of phase 1, 2, and 3, the architecture of phase 1 is actually very similar to what you've already completed in the lab that you submitted. So if we kind of juggle both of them, if I bring up the lab, I guess what I'm trying to get across here now is that you have an awful lot of the code already developed to the lab for this second assignment. And so in the lab, as you know, you've essentially kind of developed this architecture where you've got an S3 bucket. It's sending messages whenever the user uploads a image to the bucket. The bucket sends a message to an SNS topic. And we have 2, how many have we got? We've got, sorry, now let me just see. Yeah, this is a better one, actually. This is closer. Yeah, sorry. So users can upload an image to a bucket. That causes the bucket to notify SNS about that event. SNS puts the message into an SNS topic. And then we have, in the case of the lab, we've got 2 SQS subscribers, and we've got 2 lambdas feeding off of that. And one of the lambdas sends an SES email. Now, compare that picture with this, which is phase 1 of the assignment. And so it's almost identical. User uploads an image to a bucket. Bucket sends a notification to an SNS topic. SNS topic has two subscribers. So there's one slight difference here. One subscriber is a Lambda, the other subscriber is an SQSQ, whereas in the lab, both of these subscribers were SQSQs. Okay, that's only a slight change that you have to make to the code to make it match the assignment. So it's the assignment that I'm looking at here now again. This Lambda sends an SCS email. We know how to do that. You already have that Lambda essentially. This SQS subscriber has a Lambda associated with it. This Lambda here is kind of the equivalent of, in the lab, of this Lambda here. But in the case of the lab, this Lambda was essentially downloading the image locally. Now, it wasn't doing anything with it, but it was downloading it locally. Whereas as in the assignment, what I want that Lambda to do, sorry, I keep going to the wrong one. I want this Lambda just to write a record to a DynamoDB table. And we know how to do that from assignment 1. And the table schema I've given to you. And really all it's writing to the table is the name of the file that has been uploaded to the bucket. And it can easily get that. You can extract that from the message that it receives from the SQSQ. Also, what I say in the specification is, where do I say it? Oh yeah, here. I'm saying that I only want JPEG and PNG files to be uploaded to the bucket. And so if a user uploads a file other than a JPEG or a PNG file, I want this Lambda to reject it, to throw an exception. And when that exception is thrown, I want this SQSQ to have a DLQ associated with it, a dead letter Q. Now, there's no dead letter Q in the lab. If I switch over to the lab, I hope you're still with me now. There's no dead letter Q associated with this SQSQ here. And that's why I added a new section onto the end of the lab, this section here, which explains how to configure a dead letter queue. I've covered it in the lectures, but I'm giving you code here. So when you look through this section of the lab here on the left, the SQSDLQ section, then you will know how to go back to the assignment. You will know how to configure the DLQ for this guy. Okay. Now, when I say down here that I only want PNG and JPEG files to be to remain in the bucket when they're uploaded. Now, don't think of that as being a filtering, or don't pick filtering as the solution for dealing with that. The filtering won't work. Okay, so really, it's not that we're going to have a filter here. Really, the Lambda itself has to just look at the, just using basic string manipulation, look at the suffix of the file name that has been uploaded to the bucket and just check to see, is the suffix equal to the substring .png or .jpeg? So that'll be just a piece of code inside in the Lambda. And if it finds that the file suffix is one of these two, then it should just throw an exception. And once it is thrown the exception, the SQS DLQ combination will ensure that that message is now written to the dead letter Q. This is a new Lambda over here, which is reading those messages. And when it receives one of the messages, I just want it to send an email as well, just saying that, look, you've uploaded an incorrect file type. So overall, the difference between what you've created in the lab versus phase 1 of the assignment is The DLQ, the writing to the database, which you know how to do, the throwing of the exception here within Lambda, which will trigger this Lambda. And again, I've shown you how to do that in the lectures. And this Lambda writes an SES email, but you know how to do that from the lab as well, because this Lambda is essentially doing the same thing. They're just writing different messages. So I guess what I'm trying to get across is that there's very little work required on your part just to complete phase 1. If I move on to phase 2, this is where we introduce filtering into the architecture, as well as a number of other things. So in phase 2, there's a couple of things happening. I've now got 2 SNS topics, and the user can carry out a number of different types of actions. The user can upload a file as before, but the user can also, via the AWS CLI, send a message. Sorry, send a yeah, I guess I send a message to the S3 bucket telling it to delete a particular file from the bucket. When the S3 bucket receives a delete file request from the CLI, it needs to publish that event to this second topic. And this second topic has 2 subscribers, but for now we're only interested in this subscriber. It's a direct Lambda subscriber. And what the Lambda should do is delete the corresponding entry in the table, because we added a record to the table when this Lambda added a record to the table when the file was added to the bucket, provided it was a JPEG or PNG file. When the user tries to delete that file, we want this Lambda to delete that particular record. Thirdly, the user can upload a message directly to this topic. And I tell you down here that the message will also include attributes, an attribute JSON structure, and I specify exactly what the structure of that attribute JSON should be. So the user can now send a message directly to this SNS topic. For those types of messages, I want this Lambda here to be triggered. So this Lambda should only run when the message that has been received by the SNS topic is the message that was sent by the user directly. And how will this Lambda know which of the messages are those? Well, it will do attribute-based filtering on the message, because so there's 2 types of messages now that are being written to this topic. There's the delete object message, and there's this what I'm calling did I give it a name? An image description message. Okay, 2 types of messages: object delete and image description. Object delete messages should only be forwarded on to this Lambda. So we need a filter here that only allows object delete messages go through to it. Whereas this Lambda here, it should only receive messages that are related to image description messages. And in both cases, these will be attribute-based filtering. Okay, I'm giving that away at this stage, right? Okay, so this is the part, this part here now is new in the phase 2. Phase 3 then is where we have body-based filtering. I'm telling you here, sorry, before I move on to phase 3, here I'm telling you this is the structure of a message that the user can send, and this is the structure of the attributes associated with those image description messages. Okay. Sorry, is that what I'm telling you? Sorry, slightly wrong. This is the, sorry, this is the structure of the attribute. This is the structure of the actual message body itself. And I'm giving you the AWS CLI command for, I'm giving you the AWS CLI command for, well, we've actually seen this in the, we've just seen this, how you send a message with attributes. And up here, I'm giving you the AWS CLI command for deleting an object from a bucket. Okay. I'll just pause in case there are any questions, but right. So again, the message I'm trying to get across is if you cover all of the lecture notes up to attribute-based filtering, in other words, what I've covered up to now, then you can complete phase 1 and phase 2 of this assignment and potentially get 75%. And it's really kind of, it will be very easy for you to determine whether you're close to getting that 75% or not, because you'll just be obviously testing all of the, you'll be testing your architecture. So you'll be uploading an image, check to see, did my lambdas run? Did I receive an email? If you're meant to receive an email, then you'll try and delete an object from a bucket, check to see did the relevant lambdas run. Only this lambda should run. None of the other lambdas should run. Check the table to see has a record been removed from the table. And the third test will be send a message. Send an image description message straight into the topic. When you do that, you should check to see, did this lambda run? Did this lambda not run? Which it shouldn't. And, oh yeah, this lambda also updates the corresponding record in the table. And you'll check to see, was the table item updated? And by checking all of those things yourself, you can prove that the architecture is working as specified. Okay, back to the lectures. I've talked about attribute-based filtering. The next thing is, that's okay. Next thing is message body-based filtering. For message body-based filtering, the filtering criteria is the same as for attribute-based filtering. So it's string filtering, number filtering. We haven't seen any example of number filtering. And as it turns out, in the assignment, you won't need to use number filtering either. So it'll be all string filtering. So, but you do have the option of number-based filtering if a particular body attribute is a numeric value, or the simple, does the body have an actual attribute or not? So it's this exists filter, which we haven't seen any example of, and you won't need to use it in the assignment either. To illustrate this body-based filtering, well, in fact, what I need to do now is if I can do a CDK destroy of this stack because I no longer need it. So I let that work away. Now, this application is essentially the application that you have completed in the lab for submission. Okay, so if we quickly look at the CDK file, and while I'm just scanning through it, I'm going to do a CDK deploy. Okay, so let that work away. Yeah, so the application that I've just deployed now is essentially the application for from the lab. So it's deploying this architecture here. And what I want to do is to do some filtering uh, on one of the subscribers, but do it based on the body of the message. Now, sorry, yeah, so sorry, let's go back to the slides. Okay, so I'm just showing you a subset of the architecture here. Sorry, now I'm just probably laboring it a little bit, but so S3 is my publisher in this case. Okay, I'll be using the CLI to upload a file to S3, but it's S3 is going to publish messages into the SNS topic. So the body of those messages is kind of dictated by S3, right? So we need to look at the structure of those messages in order to be able to define a body-based filter. So our filter is going to examine the body of the message that has been published by S3, look for particular properties or property within it, and then if the message has a particular property, then we allow it onto the SQS queue, and then that will trigger our Lambda eventually. So the point I'm trying to get at is before we can specify the filter here, we do need to have an understanding of the nature of the messages that are published by S3. So you'd have to so I guess you'd have to take out the filter first and upload a message to S3. Eventually, it'll follow through, get to here. And then when we console log the event in this Lambda, that's where we can see the structure of the S3 message. And I'm showing it to you right here. That's what I've done. Okay. So this screenshot is showing you the structure of a message from SNS that has been passed on to SQS, where that message originated from S3. Okay. And as usual, the message is in stringified form. But if I parse that, this is what it's going to look like. Okay. So this is the body of the message that we want to do filtering on. And have I specified? Sorry, if I just go back. Okay, let's leave it at that. So this is the body of a message that has been written by S3. And so the message has a key called records, which we've seen before. The records key, its value is an array. Within that array, there is an object. That object, if we examine it, that object, one of the keys in the object is the key S3, and this is the part that we're kind of interesting. So interested in. So all of this stuff here is part of the body of the message, but we're not actually really interested in that. What we're interested in is this part here, but we still need to understand the overall structure of this message. So we've got an S3 key within an object that is contained within a records kind of outer structure. The S3 key, its value is also an object. And in particular, for example, one of the keys within this object is a key called object. That key is also assigned a JSON structure. And the key value pairs within this JSON structure is telling us something about the actual file that was uploaded. And in particular, we're kind of interested in this one here, the key called key. It actually has the name of the file that was uploaded. Okay, so we now have an understanding of the structure of the message bodies that we're going to be writing our filter for. Let's supposing this is our objective. We only want to allow messages where the S3 object, in other words, the file that was uploaded to the S3 bucket, the S3 object key begins with image, or to put it in kind of plain language. We only want messages to get through to my Lambda where the file that was uploaded, its name began with image. Okay, so if I go back a couple of slides, I want this Lambda here to only run when the file that was uploaded to S3, the file name actually began with the substring image. That's my objective. That's what I want this filter here to express. I can't stop the files being uploaded, but I only want to trigger this Lambda when certain files that are uploaded satisfy the criteria that I've just mentioned. So how do I write the filter? And it's a body-based filter as opposed to an attribute filter. And the answer to the question, how do I write the filter? Before you can actually write the filter, you do need to fully understand the structure of the message, which is why I'm showing you this screenshot here. Yeah. So record, within record, there's a key called S3. The S3, within that, there is a key called object. Within object, there is a key called key, and then we can specify a string filter on this particular part of that structure. So here's how you write it. It is actually quite long-winded, but here's how you write it. So I have my topic. I'm adding my subscriber. My subscriber is an SQS subscriber. So the filter actually applies to the SQS subscription, not to the Lambda itself, because the Lambda is just a consumer to the SQS queue. So when you see filter policy with message body, that's telling you that this is obviously a message body based filter as opposed to an attribute filter. And what you need to describe here is you need to describe the structure of the message body and focus in on the part that you are interested in from the filter's perspective. So here we're saying, well, at the very top of the message body, there is a key called records, and we saw that. Within the structure associated with record, there was an object, and within that object, there was a key called S3. Within the S3 value, there was an object, and that object had a key called object. The value associated with that object key, it was also a JSON structure, and it had one of its keys was called key, which is why we got that. And now it's only now that we can actually specify the filter condition. And the filter condition, again, is a string filter. Where do we say it? Boom, boom. Yeah, it's a string filter. And it's a match prefix condition. And the prefix, you can specify more than one prefix, but I'm saying I'm only interested when the prefix value associated with the key, called key, when the prefix is the substring image. And all of this stuff here, this policy, filter or policy, filter or policy, filter or policy, it's just kind of boilerplate syntax. It is verbose, I will admit. But you just have to, and there's a lot of opening curly braces and opening parentheses, and you've got to make sure that you close them all off down here. So it's not a very nice syntax, but so you have to be very careful when you're typing it. So that's the best I can do in terms of explaining how you write a body-based filter. You're essentially kind of describing, you're focusing in on different parts of the message body in the filter itself. Like the message body has lots of other parts to it, but we're only interested in the starting from the top, the records part. You have to, that's always going to be the first part. But from there on in, it depends on which part of the message that you're interested in. And if I go back, there's lots of other parts to the message that we're not talking about at all in our filter. We're only talking about this particular part and so on down along. So I can give you an illustration. Just make sure it works, I guess. So my stack has deployed, and I quickly look at the structure or the architecture. Same as before. I have my bucket. That's okay. I have my SNS topic. I have a queue, image processing queue. I think that's the subscriber that we're going to apply the filter to. I've got a second queue that I don't think I'm particularly interested in. I've got some lambdas. Let's just fast forward, I guess, some more lambdas. I'm adding one SQS subscription to my topic, but I'm not applying any filtering to that, so we're not too interested in that. And this is the one that has the filtering. So it's again an SQS subscription, and it's the image processing queue. And here's the filter that I told you that I kind of talked my way through. Now, the lambda that's associated with this image processing queue, we do need to know which of the lambdas is going to run, which I happen to know is going to be this lambda here, process image lambda. That's the one I'm interested in. Well, it'll either run or it won't, depending on whether the filter allows it to go through or not. This lambda is always going to run for every message because we don't have any filtering associated with the queue that's linked to that lambda, if you like. Okay, so maybe if I just try and run it. So I want to upload. I have some images here, just as you did in the lab, actually. So I'm going to upload this image using the command that you would have used in the lab. And I need to change the bucket ARN, which I have here. So I want to upload my sunflower image. I want to upload it to this bucket, and I want to call the file up on S3. I want to call it image1.jpg. Now, because the file name begins with the substring image, then eventually the Lambda that's linked to the SQS subscriber that has the filter, eventually that should run. So let's see if it does or not. Let's clean up our CloudWatch logs first. Now, because the Lambda that we want to see if it runs or not is linked to an SQS queue, so there's that polling delay, but hasn't run so far. Okay, so both of the Lambdas ran, but the one that we're interested in is which one is it? It's this one here. Oh yeah, this one here. And that's similar to the message body that I showed you in the screenshot. So, where is it? Oh no, it hasn't been parsed, unfortunately. But we can see the message got through anyway. I didn't parse it. Let me just do a search. Okay, so we can see that uh, the message has gone through anyway. Now, to prove that the filter works by not letting certain messages get through, if I send another upload, I'll upload the same image, but I'll give it a different name. I'll call it picture, that one. Like again, there is that kind of timing delay, but no matter how long we wait, we will never see a stream associated with the running of that Lambda for this upload because it doesn't match the body-based filter that we described. I'll just wait for maybe another couple of moments to give it the chance to get through, even though it won't get through. Maybe the way I can prove that it won't get through is by looking at the other log stream, because the second log stream should have received both messages. So it'll either have two log streams or one log stream with two entries in it. And I can tell from the length of that now, right, that that log stream represents the receipt of two messages, whereas the other one would still only have the log stream for one message. Okay, so it never received it. Hence, my filter worked successfully. You'd need a little bit of time now to study that how we encode the filter and linking it back to the structure of the message that the body-based filtering is being applied to. This is just a second example of what I'm doing in here. I'm saying is, supposing I change my filter and I only want to allow messages with the S3 schema version of 2. So if I go back, so it's the schema version part of the S3 message that I want to do the filtering on. And if I go back to here, where is schema version? So just let me check again. Don't do that S3, S3 schema. Okay. There you can see it there. Okay, now schema version, even though you might think it's a numeric filter, because in the message, the schema version is written as a string. We have to use string-based filtering. But in this case, the property that we're focusing in on is a direct kind of subordinate to the S3 part of the overall structure, whereas in the other case, we were down inside an object and key. So my filter in this case will look like this. Again, starting at the top of the body structure, records, look for S3, then look for S3 schema within the S3 object, and then we specify our string filter. And we're looking for, in this case, we have an allow list rather than it begins with our match prefix. Match prefix would work as well, actually, but so the allow list saying I'm only allowing messages that, in fact, that's wrong. That should be 2.0, not 1.0. Is that the way? Only allow messages with the S3 schema version of 2.0, yeah. So the filter there in the screenshot is wrong. That should be 2.0. Okay. That's message-based filtering. Back to my specification, my assignment specification, and that brings us on to phase 3. In phase 3 of the specification, we are now going back to just using one SNS topic. So there are potentially 3 different types of messages being received by this one SNS topic. In phase 2, we had 2 topics. And we need to do filtering on all of the subscribers. So for example, this subscriber here, it's only interested in object upload messages. Equally, this filter, this subscriber is only interested in object upload messages. This lambda is only interested in object delete messages. This Lambda is only interested in image description messages. In other words, these ones here. So in the case of the first two, right, for object upload and object delete messages, and I just said that this subscriber, this subscriber, this subscriber, they are interested in the object upload stroke delete messages. So these three here, their filter will have to be a body-based filter, whereas this one here is going to be an attribute-based filter. So it's quite tricky now to try and actually get those specified correctly. So it'll take you a while um, to work your way through those. In addition, I have some other stuff going on over here. I have a Lambda here that's linked to DynamoDB. Now, I need to talk about the theory behind that first, though. Which brings me back to my slides. And this slide here is just kind of a step back from, sorry, no, just give me 1 second. Okay, we talked about all of this filtering, et cetera, and SQS and SNS, and sometimes we kind of lose sight of what's the whole point of all of this. And this is the purpose of this slide here, just to remind you why we're interested in these messaging services. And it's all about decoupling your compute components rather than having synchronous communication going on between two lambdas, essentially. We insert either an SQS or an SNS, whichever is appropriate, in between them to decouple the Lambda components. Now, that's fine. We've kind of talked about those at length. There's another part to this kind of decoupling or this kind of event-driven architecture, which is to do with data streams. And I just want to briefly talk about that. This slide is also a slide that we saw way back when I started talking about lambdas from day one. And if we look at the image over here, it turns out, right, that when you make a change to a DynamoDB table, sometimes you want to trigger the execution of Lambda when our DynamoDB table changes. Whether the change be a new item was added to the table, an existing item was updated, an item was deleted, some or all of those changes, you may want to trigger a Lambda when they occur. So how do we actually achieve that? Well, this is where kind of data streams, this idea of data streams come in. And they apply to DynamoDB. It's a similar kind of a technique that's been used for triggering lambdas when an SQS receives a message, actually, and something called Kinesis as well, which is a service that we didn't look at. So this is kind of how it, again, it's a pole-based connection between them. Now, what I mean by that is, so however the database, your DynamoDB table is changed, it could be a Lambda that does it, or we don't really care. It could be the AWS CLI doing it directly. There's some source for making a change to your DynamoDB table. Now, what you can do is you can tell DynamoDB, and I'll show you how to do this in a minute, you can tell it to keep a log of all changes that are happening to the table. So as well as changing an item, adding an item, deleting an item, we can also get DynamoDB to maintain a log of those changes. And we refer to that log as a stream. Now, you can then say, I want to link a Lambda to that stream. Or put it another way, I want the Lambda service to periodically poll the stream associated with a DynamoDB table and to pull any new entries in that stream and make them available to this Lambda down here. So this Lambda is going to be receiving messages where each message corresponds to an entry in the DynamoDB stream of changes. Like internally, what the Lambda service does is it takes the entries, the new entries on the stream, and it puts them into an internal queue. And then our Lambda is fed a batch of entries from this queue, and it processes that batch, where now the batch of messages that it receives are actually logs from the DynamoDB stream. But they're just messages. And as before, the very first thing you would tend to do is, in order to understand what's going on here, is to console log the messages within the batch so that we understand their structure. So there's a couple of questions from a technical point of view. Number one, well, there's one question really. How do I set up this little mini architecture from a CDK perspective? And these are the steps. So number one, I'm saying you declare the stream in the table. So in the screenshot here, I have my DynamoDB table, but the new part is this part here. And so we're saying we're essentially telling it we want it to maintain a log stream of changes. Now, what goes into that log is being controlled by what you're specifying here. And what I'm saying is I want the new status of the item that has either been added or changed. I want its new status to be recorded in the DynamoDB stream. There are other options available to us here for this, but and I'll talk about the other options in a moment. So that means now that for this table, whenever a new item is added to the table or an existing item is modified, there will be an entry added to the log stream for this table, and that log stream will have the new status of that item. Down here is where I connect up the log stream to my Lambda function. And I'm adding an event source. Adding an event source is something that we've seen before in relation to SQS. Whereas in this case, though, the event source is of type DynamoDB event source. And we configure this DynamoDB event source by referring it to the actual table itself. So review table here is just a reference to my table. Is there an error in that code? Sorry, no. Sorry, there's an error in that. I'm saying here the table is called review table, whereas up here I've called the table my table. So they should be the same, whether we call it my table in both cases or review table in both cases. They should be the same. Sorry about that. So that's an error in the screenshot. I wouldn't worry about this property here. We can just always say that its starting point is the latest. Okay. So the effect of this line is to get DynamoDB to maintain a log stream of all changes. The effect of this code here is to connect up my Lambda function with that stream so that it receives batches of messages related to the stream. And then, you know, like I said, what you do with those messages, it depends on what the objective is, really. Okay. Oh yeah. when you're specifying that you want to stream, you control what information goes into each stream entry, and these are the options available to you. Okay. So the keys only option is saying that you only want the log stream to record the partition stroke primary stroke sort keys associated with the item that has been either added or updated. Alternatively, you want both the new and old status of the item to be recorded in the log stream. You only want the new status, which is what we saw on the previous screenshot. Or maybe you're only interested in the old status of the item. So the old status would clearly only apply when you're doing an update to a particular item in the table, as opposed to adding a new item. So that this controls what type of information is recorded in each of the log entries in our DynamoDB stream. And again, I guess if you had time, you could play around with to see what's the difference between each of these. But picking new image is probably the one that you would use most often. What are we saying here? That the event object passed to the Lambda function includes information about the, oh yeah. Obviously, there are different types of operations that you can carry out on a DynamoDB table, i.e. CRUD options, create, read, update, or delete. And which type of operation caused the state change in the DynamoDB table, that information is included in the log stream. And that may be of importance to you. It may be of importance to the Lambda. You can't do any filtering here now, right? But in the Lambda itself, maybe the Lambda that's, in other words, this Lambda here, maybe it's only interested in, let's say, delete and update operations, even though the log stream might have entries for add operations. The Lambda itself is only interested in update and delete. Well, what you would do in the Lambda is you would determine which type of operation caused the state change. And all I'm saying here is that that information is contained within the body of the message itself. And again, you would just do a console log to find out where is all of that information contained within the body of the message. Okay, if you want to use this techniques, then, well, the actual Lambda itself, sorry, is that what I'm saying here? Oh yeah, the Lambda itself, its type in this case, its type is DynamoDB stream handler, which you'd nearly have guessed, but so that is a type. So we've looked at SQS subscription handler, we've looked at SNS, SQS consumer Lambda, SNS subscription Lambda. Here's another type of Lambda handler, DynamoDB stream handler. Also in the actual CDK file, you need to include these imports, because these imports here will resolve, if I go back, it'll resolve some of the stuff that you're using here and down here. So why am I talking about DynamoDB streams? Well, as always, it goes back to the assignment, because in the third phase of the assignment, I have a Lambda here, and it's meant to be triggered by state changes that happen in the DynamoDB table. And specifically, I want this Lambda to send an email whenever a record is deleted from the table. And a record is deleted from the table when this sequence here happens. When the user deletes an image, deletes a file from the bucket, that causes the message to be sent to the SNS topic. The filtering on these various subscribers is such that that particular message will get to this Lambda here. This Lambda will delete a record from the table, and I want this Lambda to send an email when that happens. Now it may also receive, it may receive messages related to the adding of a new image or file to the bucket, or when an image description event occurs, because they're also going to cause changes to this table. So we'll need to have code in this Lambda here, which determines was the type of operation that happened to the table a delete operation? And if it was, then and only then should I send an email just stating, you have deleted file X from the bucket. Okay, so that's new in phase 3, and the fact that we're using lots of filtering here is new as well. But that's, I'll be honest and say it's quite tricky now to, you may decide, look, I'll just get the filtering working and I won't bother with this stuff here, or I'll just get this working and I'll only concentrate on some of the filtering here. I won't get all of the filtering working, depending on how much time you have and whether you can get it working or not. Right. That is the last slide. And that means I've covered really everything that I want to cover in this module. So I won't have any new material for next week. And I will start a lecture. I'll start I'll attend next week, all right, but I won't have any new material. So I guess if you've got any questions related to the assignment, that would be a good time to put them to me. I won't do a recording next week because there won't be a lecture, but I will start up a Zoom session. And if nobody turns up, that's fine. If you've no questions, but you're free to turn up and pose any questions you wanted to me. Okay, I'll also pause just in case there are any questions before I wrap up. Okay, I will touch base with you in the lab. Now, I think it's this Wednesday is the deadline for submitting the lab itself. So make sure you get that in. Okay, thanks for now, and I'll talk to you later. Bye-bye.